sklearn, cluster, MiniBatchKMeans. Description: MiniBatchKMeans is a clustering algorithm that scales to large datasets by using mini batches of data points to update the cluster centroids. This is a good choice when the dataset is too large to fit in memory. It is a faster alternative to k-means that is appropriate for very large datasets. Instead of using the entire dataset, MiniBatchKMeans uses subsets of the data mini batches for each iteration. Inputs: X. This is the input data, represented as a 2D array of shape n samples. N features, where each row is a data point and each column is a feature. Init. The method used to initialize the cluster centroids. It can be k-means, the default method, which selects initial centroids using a probabilistic approach. Random randomly selects data points as initial centroids. Outputs: labels. The predicted cluster labels for each data point, represented as a 1D array of shape n samples. Cluster centers. The coordinates of the cluster centroids, represented as a 2D array of shape n clusters. N features. Steps: initialization. The algorithm starts by initializing the cluster centroids. Mini batch iteration. The algorithm iterates over mini batches of data points. Centroid update. For each mini batch, the algorithm updates the cluster centroids by moving them closer to the data points in the batch. Convergence. The algorithm stops when it reaches a predefined convergence criterion, such as a maximum number of iterations or a minimum change in the centroids. Metrics: inertia. This metric represents the sum of squared distances between each data point and its closest cluster centroid. Silhouette score. This metric measures the quality of clustering, where higher scores indicate better clustering. Visualization plots: scatter plot. This plot can be used to visualize the data points in their assigned clusters, with different colors representing different clusters. Elbow method plot. This plot shows the inertia of the clustering algorithm as a function of a number of clusters. This plot can be used to determine the optimal number of clusters. Fine-tune parameters: batch size. The number of data points in each mini batch. A larger batch size will result in slower updates but potentially better accuracy. N clusters. The number of clusters to form. Maxiter. The maximum number of iterations to run the algorithm. Init size. The number of data points to use for the initial centroid selection. Uncertainty methods: none. MiniBatchKMeans does not provide uncertainty methods. Challenges and fixes: Challenge 1. Convergence issues. The algorithm may not converge to a global optimum and might get stuck in local optima. Sample use case that resulted in challenge 1: a dataset with non-spherical clusters or overlapping clusters. Fixes to challenge 1: try different initialization methods, such as k-means or random. Increase the number of iterations. Adjust the batch size. Challenge 2: slow performance. The algorithm can be slow for very large datasets. Sample use case that resulted in challenge 2: a dataset with millions or billions of data points. Fixes to challenge 2: use a smaller batch size. Use a faster initialization method. Use a distributed computing framework.